A brief description of firing circuits have demonstrated properly in this session. To fire an SCR, we should implement the gate pulse across gate. So, there must have some proper circuit through which we are applied the gate pulse. Two types of firing circuits are normally used to fire SCR: resistive firing circuit and capacitive firing circuit. In case of resistive firing circuit, we can control the firing angle from 0 degree to 90 degree, but not more than that. So this is a kind of drawback for using resistive firing circuit to fire SCR. That can be overcome by using capacitive firing circuit, through which we can control the wide range of the firing angle from 0 degree to 180 degree. So at first I am going to explain the resistive firing circuit in details. Before explaining the resistive firing circuit, let me clear one thing: how the load voltage can be appeared across load. And during this case, we consider a simple network which is having an AC supply Vs, the thyristor T, and a resistive load, suppose R, and voltage across the load resistance, that is suppose VL, and voltage appearing across the thyristor T, that is suppose VT. So this all voltage can be represented by some axes. Okay, consider there is a 3 axis. Number 1, that is for supply voltage Vs. Number 2, that is load voltage VL. And last, that is terminal voltage across the thyristor, that is VT. Okay, and consider as we are using Vs, so we can draw a sinusoidal wave, and this part is pi, and consider this is suppose 2 pi. That means we consider a fundamental cycle 2 pi. Now during operation, what happened? When we applied Vs and the supply voltage goes positive as the nature of the sinusoidal wave, then the thyristor will be in forward biasing condition. But still this is not under conducting state, as we are not applied any gating pulse across the gate. Once we apply the gating pulse across the gate, then the thyristor becomes on. Once the thyristor becomes on, then the supply voltage starts delivering the current throughout the circuit. That means load voltage which will follow the supply voltage. Okay, that means we can say when the thyristor is not under working state or the thyristor is in off state, then the total voltage will be appearing across the SCR, that is defined by Vt. Once the thyristor starts working and becomes on, then supply voltage will be reflected on the load, means that can be replaced by Vt. Okay, you can put an example for easy understanding. Suppose when you switch on, then what happens? Then maybe the load starts working, means the fan starts moving, means the light starts glowing. That means what? When we switch on, then the voltage is appearing across the load or across the fan or light, whatever. That means then it starts working. But when you not switch on, that means what? The switch is remaining open. That means the total voltage is appearing across the switch. Okay, that means actually the voltage will be distributed in this way. When the switch is closed, then the voltage will be appearing across load. When the switch remaining open, then the voltage will be appearing across the switch only. The same thing we can be represented through this axes and the diagram. Consider we are applying the gate pulse across gate, suppose with an angle alpha. That means 0 to alpha, the thyristor is not working. right? So consider this is alpha. We are having the gate pulse with an angle alpha. So we can assume this dotted red line. What happened? Then the device starts working. Then the voltage across the load that will follow the supply voltage. What is supply voltage? This is the waveform of supply voltage up to pi. So we can assume once we apply the triggering pulse across the thyristor with an angle alpha, then the thyristor starts working and immediately the source voltage will be appearing across the load. That means this total thing that will be appeared across the load or VL. The waveform will be similar to each other as the exact amount of supply voltage is reflected on the load voltage. That is, the waveform will be same. Okay. Now the question is, when the switch was in off state, what happened? Then no voltage is delivering across load. That means total voltage is delivering across the switch. That means up to this point means 0 to alpha. That means the device was in blocking state. That means it was able to block that amount of voltage that can be appeared by the supply. That means the terminal voltage will be this one. Okay. So that has to be taken from this part, terminal voltage. That means we can say the total voltage, the supply voltage is distributed in this manner. When the switch is on, then the supply voltage should be reflected on the load voltage. When the switch is off, then the total supply voltage will be reflected or blocked by the switch or thyristor, that is VT. So in this way we can say actually the supply voltage can be distributed and load voltage will be appeared across load. Okay. So this is all about for the forward biasing case or in case of the first half cycle 0 to pi. In this case again we can say we can change this firing angle by using appropriate firing circuit. That is why we consider resistive, capacitive, like this kind of firing circuits can be applicable to fire the SCR. Okay. Suppose we can change the firing angle. In this particular case, the firing angle was what? Alpha. Suppose we can change the firing angle or we can increase the firing angle from alpha 2 with an increased value alpha 1. Then thyristor can be fired at this point, right? Then what happened? Then the waveform can be changed in this way and it will be blocked up to this point. That means we can say if we are increasing the firing angle or decreasing the firing angle, the width of the output voltage can be varied. Okay. That means if we can take the average output voltage to the load, that means the output voltage can be controlled or regulated. That is why this is called control switch, through which we can control the output wave shape as well as the output waveform or current waveform. Okay. Now for next half cycle, means I am talking about that is pi to 2 pi or this point. What happened? So thyristor was in conducting state up to the point of pi. After crossing pi, what happened? As we are using the AC signal, that is why the voltage goes to in negative. That means immediately the thyristor will be in negative biasing condition, as well as the current is exactly 0 at the point of pi because there is a no load voltage or no supply voltage. That means current is 0. That means what happened? You consider, we know thyristor can be switched off by reducing the anode current below holding current. That means what? And that can be possible by using the reverse biasing across the thyristor. Same thing can happen by using this kind of AC signal. After crossing pi, the current is 0. Then we are still applying the reverse biasing, that's as a normal sine wave. Okay. That means once the thyristor is in reverse biasing condition as well as the current is 0, that means easily we can say this is a kind of natural commutation through which the thyristor will be switched off automatically when the reverse cycle starts. So this is all about for the conduction case in case of thyristor, and how the load voltage will be appear across load. This is the actual reason. Now we can go into the topic in resistive firing circuit. This is a schematic circuit diagram of the resistive firing circuit, in which we are using the AC supply, that is ES equal to E max sin omega t. A load is there and the load voltage is defined by, suppose, EL. Three resistances are there to design the proper resistive firing circuit along with a diode. This is gate terminal of the thyristor. This one is the anode part and this is the cathode part. And the voltage across gate to cathode, that is suppose VG, and the gate current is suppose defined by IG. Normally, the load resistance have kept is very small in magnitude with respect to other resistances. Whereas the normal specification, the other resistance, suppose R min, RV and RB, that is about near about, that is kilo ohm amount, and in case of resistive load we assume that is a few amount of ohms. Okay, that means what? If we consider the load resistance is very small in magnitude, that means whenever the device starts conducting and the thyristor starts conducting, immediately the supply voltage will be reflected on the load terminal. There will not be a very small amount of voltage drop. That is why we can achieve the appropriate amount of output voltage waveform. Now the operating principle. When the supply voltage goes positive from 0 to 180 degree, then what happens? Then when the supply voltage reaches to a particular value or with a high magnitude, along with, suppose we are applying the gate pulse across it, then what happens? Then the current starts flowing to the gate as well as the current starts flowing to the thyristor also. As they are using the so many resistances, as well as assume the thyristor is under blocking state at the increment of the supply voltage as a normal nature of the sinusoidal wave, then suppose the gate is fired and gate current starts flowing through this in this way, and then the thyristor will be in on state. Once the thyristor will be in on state, then the supply current is easily starts flowing throughout the circuit in this way. Then the supply voltage is reflected on the SCR. So just I have discussed in previously. So in which we can say, suppose assume the gate, we are applying this gate current from the supply with some delay angle that is defined by, suppose, alpha. Alpha is called actually delay angle of the gate firing, the delay angle of the gate pulse, that is defined by alpha. Once the gate is fired, when the thyristor is fired by this amount of the gate pulse, which is defined by this dotted line, and this is for the 180 degree lines, and this axis defined by the 360 degree. That means what? When the thyristor switched on at the point of alpha, then immediately this load current that should be followed by the supply voltage, that is defined by this one. And when the switch was in off state, when the device was not in the working state, it is working as a open circuit, then the total voltage is appeared across the load. That is why VAK defined by this one. And once as per the normal behavior of the sine wave, when the wave goes after 180 degree, then we can say then the switch is in the reverse biasing condition, because after 180 degree, the polarity will be changed. It will be positive, it will be negative. Then we can say the anode is more positive with respect to cathode. Then we can say the switch is under reverse biasing condition. That is why, as well as at the same time, the current is appearing across the thyristor, that is 0. That is, we can say this is a normal commutation technique. Then the device will be in off state automatically. That is why 180 to 360 degree, there is no voltage is appearing across the load. Then the total voltage is appearing across the switch. That is why the switch voltage will be, the waveform of switch voltage will be from this point to this point, again until we are not applying the next triggering pulse up to the point of again 360 degree plus alpha. That is why up to this point, I am talking about 180 degree to 360 degree plus alpha. In this particular time, the switch was in off state. That is why total voltage is appearing across the load. And as we know, the total voltage is appearing across the thyristor. And as we know, this will be followed by the supply voltage. So we can see from 180 degree to 360 degree plus alpha, the nature of the waveform is this one. That is why we can draw the same nature of the waveform across the VT or the terminal voltage. That means again we can conclude when the switch is on from alpha to 180 degree, the voltage will be appeared across load. When the switch is off, suppose 0 to pi, again from 180 degree to 360 degree pi, the voltage will be appeared across the switch. In this resistive firing circuit, normally we are using three resistances along with a diode: Rmin, RV and RB and diode D. Now, why we are using this kind of resistances? Rmin, it has a particular amount of minimum amount of value up to which we can permit the maximum amount of the gate current across gate. RV, which is actually a variable resistance and normally used for controlling the shape of the output voltage. RB, which is termed by stabilizing resistance and normally it is used to protect the over voltage from the supply and which is connected across or parallel with respect to gate to cathode terminal to limit the gate voltage up to a certain value that is defined by Vg. And diode plays an important role during reverse biasing condition. When the current try to flow from cathode to gate, it can protect this reverse biasing current or oppose this current. So in this above circuit, normally Rmin, RV, RB are is in kilo ohm amount, whereas the load resistance are in very few amount of ohms. So the load is very small with compared to other resistances. So we can say as the resistance of the load is very negligible, so the voltage appearing across the load, that is EL, that should follow the supply voltage ES. The detailed description of the all components using in our firing circuit and described here properly. First, consider D or diode. Diode D prevent gate cathode reverse biasing from exceeding from peak reverse gate voltage during negative half cycle of ES. In some case, peak reverse voltage ratings should be greater than Emax. How it can be clear? Suppose go to the previous slide. See, in this case, we know after crossing pi, at the first case, first you think about 0 to pi or 0 to 180 degree. What happened? That means in this case, this upper part of the supply is positive and the lower part is negative. Then current can easily conduct in this direction. But after crossing just pi or 180 degree, then what happened in case of pi to 2 pi? That means what happened? We know after crossing just pi, that means the polarity will be changed due to application of the AC. It will be positive and it will be negative. Then current try to flow from this direction to this direction. That means current try to flow from cathode to gate, and it can be maximum at the point of exactly in this position. As we know, in case of the sine wave, it starts from 0 with a very low in magnitude. Again, it is increasing and it will take the maximum or it will reach the maximum or peak value at the point of 90 degree. Same thing can happen in case of the next half cycle or negative half cycle. So when after pi, when the negative biasing reach to a maximum point at the point of 270 degree near about, the maximum negative current try to start flow across the gate to cathode. So we can say in that particular case, see, when the negative current means cathode to gate try to flow, as the diode is there, as it is in reverse biasing condition, then it is able to block this total reverse current or negative current. So this is the use for the diode D. Now Rmin, what is it? When applied voltage is maximum and reaches the maximum value, that is suppose Emax, at the point of 90 degree, then the current through the resistance circuit to the gate should be maximum. Suppose it can reaches up to the point that is Ig max. In this case, Rmin is used for limit this gate current in a permissible value, and it should not be exceed Ig max. If it some under any circumstances, suppose the Ig max is more than suppose its rated value, then the junction J3 can be permanently damaged. That is why, to protect this particular thyristor from the high heat phenomena or overheat phenomena, normally we are using that is Rmin, which is normally used to prevent the not excessive current to which try to flow across the gate. It is normally used to permit the permissible amount of the gate current gate to cathode, okay, and which can be expressed by Emax by Rmin. That means when the supply voltage has reaches the maximum value, that is Emax, at the point 90 degree, then obviously the circuit current that should be limited by Rmin. That means we can say Rmin is working as a simple resistance. That means voltage by resistance means Emax by Rmin, that should be less than equal to Ig max, not more than that. That means total this thing is normally protect the maximum current which cannot be flow to the gate terminal. So after simplification, we can write the expression, the value of Rmin that should be equal to, that should be greater than equal to Emax by Ig max. This is the actual expression. Now the very important part, that is RV, that is called variable resistance, that is normally used to control the shape of the output voltage. As we know, the gate current can be from 0 to Ig max within a permissible amount within the limit to applicable to by using the Rmin with the value of the supply voltage 0 to Emax, as it is a normal sine wave we are using. That means what? Suppose we are adjusted the value of RV in a particular point at which the thyristor can be fired. If we are increasing the value of RV, that means thyristor firing angle will be increased. Then that means we are inputted some amount of delay. That means we can control, or by adjusting RV from low value to high value, we can permit the permissible amount of the gate current across the gate. Okay, that is why we can say if we can say if RV is minimum, that means alpha should be small in magnitude. If RV is maximum, then alpha should be very high in magnitude. That means we can control the entire region of 0 to 90 degree to fire the SCR, or alpha or the firing angle can be controlled by using this kind of resistance or variable resistance. That means if we can change the firing angle by using or by proper tuning of this variable resistance, that means the output voltage can be varied, the output voltage can be decreased or increased. That is why we can say we can control the shape of the or width of the output voltage by using this variable resistance. That is a very important part for this resistive firing circuit, how we can control the output voltage by using RV or this variable resistance. Okay. Now the question for RB or stabilizing resistance. Normally it is connected across the gate and cathode terminal. That means what? That means as it is connected parallelly with respect to gate and cathode terminal, that means it is able to protect the over voltage across gate to cathode. Somehow, when as a normal behavior of the sine wave, when it can reaches the maximum value at the point of 90 degree, or that is defined by Emax, then what happened? Then maximum amount of gate current, that is Ig max, starts flowing up to a permissible amount by proper adjusting of RV and by using of the R minimum or minimum amount of resistance. That means, but somehow it can be possible, that is when the supply voltage has reaches the maximum value, then the voltage appeared across gate to cathode, that can be maximum. That means that can be defined by Vg max. So the Vg max should be under a permissible amount, that should be restricted by using this resistance, which is defined by Rb or stabilizing resistance. Now the question is arised, what will be the value of VG or VG max. VG actually defined by the voltage across gate to cathode. When the supply voltage reaches the maximum value, then it can be defined by VG max, as the voltage across the gate to cathode should be maximum. So what will be the value of VG max? So it can be defined by a simple expression and using the voltage dividing law. And I think it's known by everyone. In case of voltage dividing law, whenever we are going to calculate any voltage across any load resistance, then what we will do, then it should be equal to original voltage or supply voltage multiplied by that load resistance divided by total loop resistance, right? Same thing can happen in this case also. See, whenever we are going to calculate the VG max or maximum allowable voltage across gate to cathode, that should be equal to, means VG max equal to E max, because VG max will appear when E max will be maximum. That means VG max should be equal to EG max into this resistance, means RB, divided by total loop resistance. This is the loop, if we consider, that should be equal to divided by Rmin plus RV plus RB. So we can write the expression in the similar way, that is VG max, that should be equal to E max into RB by Rmin plus RB plus RV. So after simplification, we can rewrite the expression, that is RB equal to E max minus VG max, that should be less than equal to VG max into Rmin plus RV. So the value of RB, that can be defined by this expression. So this is the actually design value of RB, up to which we can able to generate the allowable gate voltage across gate to cathode. That is RB less than equal to VG max into Rmin plus RV divided by E max minus VG max. So this is all about for the resistive firing circuit. That is why we can conclude we are using the particular amount of the resistance value for Rmin, RV and RV, through which we can apply the permissible amount of the gate current as well as the permissible amount of the gate voltage within a particular value or region, up through which the switch can be operated without any disturbance, and no accident will be occurred during using this kind of the proper resistive circuit. So this is all about for the resistive circuit. So thank you.